This video is about developments in technology. Now, quite often this comes up in the A2 exam where you have to choose some products, or it might give you some examples of products, and you basically have to explain how new technologies or new materials or smart materials in some case have developed the product, have made it improve over time or over years. There's many examples of where you could discuss how technology has developed. Some of the key ones that are covered in the AQA textbook are in the audio realm of products, I suppose. So it starts by taking you through a case study, I suppose, over time, where it first talks about valve radios and then the introduction of transistors, replacing valve radios for a transistor radio. Then there were developments in manufacturing technologies to allow, for example, injection molded cases to make the radio more portable. We then moved on to, again, miniaturization of electronics, allowing for portable audio, such as in the Sony Walkman, moving on further into MP3, and then effectively going into, I suppose, streaming services such as used today for things like Spotify or Deezer. In addition to audio, you could also talk about developments within the visual communication side of things, so relating to television and things like this. So starting off with analog televisions, then the signal was moved to a digital television signal, and then lots and lots of development in high definition screens through plasma and LCD, and also sort of front and rear projection for a while as well. We talked about developments there. And the other, I suppose, key area they talk about in the book is in the realm of communication. So it starts off with like a telegraph system, just operating on a system of electrical pulses that allow a series of marks to be made in a Morse code style. Moving on to the rotary dial telephone, moving on further there in terms of cordless telephones, again through a miniaturization of components and things, and eventually moving into mobile phones with the introduction of printed circuits or microchips, great chips as you may know them. Now, you can learn case studies, and this is very useful, and I suggest doing this, looking through the book and learning how some of these technologies developed. But this question is very much about your understanding of how, I suppose, technology has developed as a whole, your sort of holistic understanding of some technologies. And in a sense, you could pick a range of different products to discuss in this type of question. Now, I suppose some of the key things, though, some of the key sort of advances in technology have been kind of in the area of electronics and later in the digital age. So 20th century, I suppose, there was lots of developments in electronics, and then we've moved into more of an information age where the internet has enabled many technologies. But in terms of thinking about how these things have changed, I like to break this down into 5 key points. The first is the reduction in power. Now, we talked about the radio before, how we've gone from transistors into integrated chips, and in fact before that the valve amps, and the result in this is the reduction in power, and this is one of the key things that have allowed devices to become more portable, and also has developed the idea of batteries being used to power devices as opposed to a 240 volt power supply as you'd find at home. Now, the other key development, I would say, is the use of electronics replacing mechanical parts. Now, this links very closely, obviously, into power. So by taking away moving parts, it's allowed products to last longer and allow them, again, to be more efficient. In addition to this, through electronics as well, and then moving into miniaturization of components. So again, linking to the idea of many transistors being placed on one integrated circuit or microchip or chip as you might know them, has allowed much more complex devices and a lot more features to be applied on products. So if we compare, for example, a Walkman, which maybe just plays music, to the latest phone or MP3 player, I suppose if we went back a few years, that now allows us to take video calls as well as play music and video and access the internet and so on and so forth. This miniaturization has allowed this, but again, it's still linked to those other areas of electronics and the massive reduction in power drain on some of these components and products as well. In addition to this, the switch from analog signals to digital signals for transmitting information and data has been a big driving factor in the development of things like televisions and audio as well, where we've moved from analog sound on audio to the more digital streaming situation, and it's been reduced down so we can transmit lots of data and be more efficient in that sense. And finally, the development or the use of software over just hardware changes. So if you've got an operating system like iOS or even Windows, for example, we can develop the product quite greatly through software upgrades, as opposed to if we went back many years where if we wanted to upgrade something, the simple solution really was a hardware change. So we'd have to sell the product or dispose of the product in some way and then buy the next one out. Whereas nowadays, you can hold on to a device and it can be developed through a series of software updates over the years. Going back to answering this in the form of a question, we can choose a product and we can think about these 5 criteria when we're discussing how to answer this question by using the following mnemonic. Now, the mnemonic is: powerful electronics cause the miniaturization of digital software, with the key 5 words there being power, electronics, miniaturization, digital, and software. And if we can use those 5 key words when we're discussing modern technology, it's going to give us a whole range of things to talk about within that question. Now, going back to the AQA textbook again, there are another range of different technologies that they talk about, and these can be broadly broken into a few different areas. Now, one is the internet and access to data, and obviously you can see many links and how the internet has affected many different products, from, as I say, mobile phones to computers and laptops to even televisions that are now connected to the internet. And this links us into this idea of intelligent systems and products that are interlinked together. Okay, you may have even seen something like the Amazon Dash button that's just come into play recently, and it's kind of like a movement on from refrigerators that order products when they run out, and effectively you click a button and it will order a new product for you. So you might have a button for your washing detergent or your razors or something like this. In addition to this, products that can be programmed. So I suppose this started off with things like video recorders where we can set a time on it, and even sort of systems like your boiler and things that control your heating in the home. But this has gone way beyond this now, where we can program devices to do a whole range of different things and link into things like smart houses and even products that we can enter a few details and it almost intelligently learns how we operate and where we go to work and adapts our content accordingly. It can even learn our sort of natural speech, and you can see this in things like predictive text and things like this. In addition to this, the communication between interlinked products, so starting off initially with infrared control of things like televisions and just basic ability of being able to turn things on and off, has now moved into Bluetooth to send files and take away cabling to connect products together, and even wireless communication now, which can be used to transmit huge amounts of data quite quickly. The other key area that the book talks about is in nanotechnology, and it talks about a range of different applications for nanotechnology, which I suggest you maybe read into and focus on in more detail. But one thing it talks about is radio frequency identification tags, RFIDs for short, which effectively are kind of like a development from a barcode where we can scan products and learn information about them. Fluidic self-assembly, or FSA, so this is the manufacture of very small microchips or IC chips on almost like the molecular level. Sensors within airbags that respond very quickly, also using nanotechnology there. You might have noticed it in a range of different smart textiles, whether it be things that we wear, such as the stain repellent or resistant fabrics that is used by sort of Gap and Levi's in their Commutergene products and things, and also products that have antibacterial properties to reduce the need for continual washing and also to make products safer, as in plasters and things like this. You also see these in nanofilters for water that can improve the quality of a product through reducing viral and biological agents, and in synthetic bone replacements whereby calcium and phosphate is modified to make replacements there. And obviously we've got a whole range of smart and new materials that you could also talk about in terms of development of technology. So effectively, if we use the mnemonic there, powerful electronics cause the miniaturization of digital software, and we can focus on the ideas of the internet, interlinked and intelligent systems, and nanotechnology, smart and new materials as well, we can have a very good approach at answering this question. But we obviously have to think of a range of products and have a bit of a holistic view about what is new in order to answer this question effectively.